be taking 2 to 3 machine learning algorithms and providing a hands-on session using MATLAB, I guess. And if time permits,
Yes.
he'll be using Python as well in the afternoon session. So kindly requesting all the participants to make the best use of this. And you can interact with the resource persons as well, because they're having, especially Dr. Pramod, I guess he's having good experience. So you can interact with him, you can get your doubts clarified, you can have more solution to your research work as well. So may I now request Priyanka madam to introduce Pramod Kumar.
Thank you, sir. Good morning to one and all. Myself, Priyanka, assistant professor in the Department of ECE, Lendi Institute of Engineering and Technology. It's my pleasure to introduce Speaker of the Day, Dr. Pramod Kumar Garu, who is currently working as Senior Technical Manager at AICTE. He has over 15 years of experience. He completed his PhD at VTU, Belagavi. He is an IBM and Simply Learn certified engineer in artificial intelligence. He worked as lead engineer for MathWorks products at Bangalore for 3 years and was resource person for almost 65 workshops or FDPs. He completed training for almost 90 scientists of BEL at Bangalore for 1 week on MATLAB for signal and radar applications. He also conducted cooperative training for defense. Worked as coordinator of BOE for E&W Board of Belgaum region and also worked as valuation coordinator at Center Valuation Center VTU. He has done MTech project at Center for Robotics and Artificial Intelligence, DRDO Bangalore. He has built proof of concepts based projects for HAL and DRDO. Now I request Dr. Pramod Kumar Garu to continue with the session. Thank you, sir.
Thank you, sir. Thank you, ma'am. So thank you for that warm welcome, ma'am. And thank you everyone for providing this opportunity. So I hope my screen is visible to everyone.
Yes, sir.
Yeah, it's good enough, Pramod. You can go ahead. This is Ramesh here.
Yeah, Ramesh. Yeah. My name is Dr. Pramod Kumar Nayak, and I'm working as a senior technical manager at Apply Volt Technologies Private Limited. And I also have my co-founder, Mr. Ramesh Naidu. He has over 20 years of experience, and he has worked in various domains, like as a product manager in Corel Technologies. We were colleagues there, and finally, currently I'm working with him from a couple of years. And you can see most of you who are attending this session would be aware of Ramesh Naidu, and you are interacting with me for the first time. So I hope whatever session we'll be covering in terms of agenda, I'll just brief you as we go further with our session. And today's session will also focus on machine learning and its application, and we'll also look into like how exactly the data scientists work. We'll take few examples in terms of IoT and various aspects, so that whoever is attending the session would understand like where the data is coming from, how exactly machine learning algorithms is applied. And then in the afternoon session, that is from 2 to 4, we'll switch to deep learning. Okay, so that's the general flow which I have in, but in brief, the agenda I'll brief you as we go further with the session. Okay, now as we discussed here, as we know that we welcome you to this machine learning and application. That's the phase 1 6-day short-term training program, which is sponsored by AICTE. I thank the entire department of ECE, Lendi Institute of Engineering and Technology, which is an autonomous college. And I thank also AICTE for providing this sponsorship. Now, taking further, as we all know that this entire session would be taken care, that's entire day would be taken care by us, that is Apply Volt. We are a technology company formed by veteran technology researchers who have more than a decade of experience. And you can see that we have our own customized FPGA boards, IoT platforms, embedded, say, devices, like we have ARM Cortex-7, Zinc SoCs. So these are different FPGAs and ARM processors, which we sell it to most of the companies as well as educational institutes across the South. We also have antenna prototyping technology, where we provide PCB machines to most of the college. End-to-end PCB, that is two-layered PCB machines are being provided in. And if anyone is interested in terms of pricing, I think Ramesh Naidu would be the right guy who can talk about pricing. We are also focused in setting up center of excellences in the area of artificial intelligence, machine learning, and we also conduct training in terms of corporate as well as in terms of educational institutes also. What we offer, we basically, our product solution are associated to electronics as and mechanical products. So as far as service areas are concerned, our basic know-how is in terms of VLSI design, both front end and back end. We have a set of engineers who actually develop cutting edge technology in terms of IP designing, where we have our own patents in terms of video processing IP. Now, if you go to the Xilinx website, you can see the details of the IP which we have created in. And if you type my name, you would be able to see the IPs which have been registered under my name. And then you can also see the details associated to Dr. Hansraj Gulait, who is a professor in IIT Mumbai. So we have collaboratively worked with him and we are able to create patents, right? So as far as the PCB and artificial intelligence technologies are concerned, we also provide customized solutions. If the college is having a specific funding, based on that, we can set up your center of excellences. It's not only in terms of providing you with the software, we also have hardware solutions. Like we provide AI edge devices also. Like when you talk about AI edge devices, probably in phase 2, we'll be demonstrating those platforms to you guys. You might have heard about platforms like NVIDIA GPUs, but we provide platforms to uh, colleges in terms of which are low cost, which starts somewhere around from 15,000 and goes up to 2 CR. Okay, so there are different variants of platforms. When you talk about NVIDIA, there is NVIDIA Jetson Nano, TX1, TX2. If I talk about a normal system where you are trying to develop your artificial intelligence algorithm, it would generally require somewhere around 4 cores, okay, to do the processing. But whatever that NVIDIA Jetson platform, which I just mentioned, is having somewhere around 256 cores in it. Okay, 256 CUDA cores in it. So you can imagine in the speed of operation. Okay, so whenever you want your machines to work efficiently, you require high computing machines as such. We also deal with Google Cora board. Google, I think everyone is aware of it. They are also into artificial intelligence, and we have a board called as Google Cora, and this is also a low cost board where it is a TPU. So whatever TensorFlow algorithms are there can be directly run on those platform. Okay, so as far as Ramesh Naidu is concerned, I think this is his contact number. So whatever details you want in terms of whatever platforms I said, this is one of the number which you can reach us. This is the detail of Ramesh Naidu, and we have office in Hyderabad as well as Vijayawada, and he has over 20 plus years of experience in electronic industry. Okay, and this is my detail. I think already my details and the brief is being done, so let's not focus on that. And as far as the technology partners are concerned, these are our technology partners. We are associated with NVIDIA. We also sell various FPGA boards and SoCs which are being developed by what is called as Xilinx. Okay, and we also distribute boards from Digilent. Okay, and we also have our own IoT platforms, which is your LoRa IoT platform. We have fabricated it here in India. Okay, and probably next week we are releasing our LoRa based IoT platforms, and this is also an industrial IoT. Okay, so we have fabricated it in Mangalore, and the latest boards, I think probably next week, we would be releasing this platform. So it is like a plug and play device where you want, we'll give you somewhere around 26 sensors, okay, which is just like a plug and play. And for industrial, I mean, pricing, it costs you somewhere around 6,000 rupees per board. Okay, so it's basically a microcontroller Arduino configured board. Okay, so that's one of the platform which we would be releasing in. And As far as answers is concerned, we also have speed code simulation and testing. Okay, so this is one of the platform which is extensively used in terms of say building real-time applications. Okay, so this is one important thing uh, which you have to look into it. Okay, now highlights of this particular session is that, okay, this first initially let me spend a couple of minutes on introducing artificial intelligence. Then we'll introduce the concepts of big data, data analytics, and then we'll take a small example. So whenever you talk about machine learning, you require data, right? So which are the websites from which you can go ahead and download data, that we'll check in. We'll also introduce a few machine learning algorithms, and then we'll also build an hands-on expression or a program or a classifier learner app we'll use, and then we'll apply machine learning algorithm on that data set which we have received in. We'll also introduce like how exactly, if there is a large data, we also call it as big data. So if there is big data, how exactly you can manage those large amount of data is what we'll be looking into it. And then as far as deep learning is concerned, that would be in the afternoon, that is from 2 to 4, we'll be switching towards deep learning. Okay, and then followed by that, we'll also talk about how exactly deep learning workflow is happening in MATLAB. And during this, we'll also talk about visualization in terms of the training process. Like whenever you are performing what is called as transfer learning, how exactly the training process is being done, what is meant by ReLU layer, what is meant by convolution layer. So all those things we'll be just checking in. And then we'll be uh, also talking about various boards, including Xilinx FPGA, GPUs, and then there is a toolbox called as parallel computing toolbox, which would increase the speed of operation. So all these things we'll be just discussing as we go further with our today's session. Okay, so for 5 to 10 minutes, I request all the participants to note down few of the points here that would give you an insight in terms of what is meant by artificial intelligence. So that will give you an idea like in terms of how exactly the technology is being out there in terms of artificial intelligence. So all these things we'll just cover as we go further with our session. At any point of time, if there are any queries, you can just stop me and then you can put your questions, or after every couple of slides, I'll be just going and addressing those questions. I think that would be ideal. So welcome everyone. Let's go ahead and talk about or brief about what is called as AI. Okay, and then we'll take it further in terms of artificial intelligence. So whenever you talk about artificial intelligence, it's the intelligence demonstrated by machines. Okay, unlikely natural intelligence displayed by humans and animals. Here, what we are talking about a study of artificial intelligent agents, where you will be having an perseverance of environment which takes action that maximizes the changes of successful achieving the corresponding goal. So for example, if you talk about a machine, okay, which is being used in say IoT, industrial automation, chip designing, right, anywhere, you as a person, you would be able to actually model those machines or train those machines to give you the specific output. The simple example for that is when you go to trivago.com, okay, or when you see the ad of trivago.com, you generally see that there is an ad which has been popped out. What does the ad say? The ad basically says that, okay, if you are locating to some new place or relocating to some new place, we check the different pricing of hotels, and then we give you which is the cheapest one. Okay, it checks the pricing of hotels in different website and tells you which is the cheapest one, right? So if you look into you being an IT trainer, you can see that these days AI agents, okay, where uh, last day I had a session at Infosys Bangalore here in Electronic City. We were discussing in where the entire web designing. Okay, so we talk about the web designing, right? So the entire web designing, the UI development is being carried out by and machine learning. So if you want a website, so directly if you are an IT trainer, or say for example you have a couple of kids who have to train at a specific technology, you tell the AI agent to train them, right? So it will be having a recorded set of videos, then it will explain the exact functionality. You can interact with the chatbot, and then it will search the answers and it will give you answers within no time. Or in terms of website also, you just feed in the images, and based on those images it will start giving you say websites within say 7 minutes, and then it will give you the color combination of somewhere around 50 different color combinations of your website. Okay, so such kind of things are currently going on in terms of artificial intelligence. As far as service strategists are concerned, you talk about any domain. It might be in terms of cloud computing, internet security, cyber security, robotics, industrial automation, okay, or smart factories, or it might be chip designing where you want to reduce the area of chip, or it might be reduce the power consumption, or it might be in terms of industrial IoT where you would be able to apply machine learning and deep learning to understand and also predict the behavior, right? Say for example, during this COVID situation, you saw that Tesla Motors was one of the company which was manufacturing its vehicles, okay, where the employees were sitting remotely in Boston, and via what is called as industrial IoT, they were controlling the KUKA robots, okay, and which was remotely controlled, and then they were able to manufacture the electric vehicles at a faster rate, right? So such kind of technology is out there. And as an entrepreneur, you can see that there are almost around 154 companies which are set up in Bangalore. Okay, I'm not talking about India, in Bangalore. And they basically deal with AI products, consultation and implementation of the algorithm. One such company which I came across was Halli Technologies, Halli. In Kannada, the meaning of that is village. Okay, there was a company called as Halli Technologies, which has been taken over by Google. So this was one of the company which was founded by 5 to 6 engineers here in Bangalore, and that company is being taken over by Google. Okay, now as far as the technology is concerned, when we talk about AI, people generally say that uh, it's out of the box technology. But let me tell you, we are already using these technology in our daily life. If you talk about virtual assistants, like everyone is aware of Siri, Google Assistant, or it might be Microsoft Cortana, Amazon Echo, right? So these are few of the technologies where you can schedule your calendar, you can capture the live weather data, or you can check your flight status, all those things using the virtual assistant, you can do that. As far as technology used in automotive sector, we also have what is called as Tesla Autopilot, okay, which was the dream project of Elon Musk. We have Google Vimeo. I'll show you these videos as we go further. And then we have Ford Argo AI. So these are few of the technology where these vehicles are also in India. Okay, and they are also in the testing phase. Okay, so already I'll show you few of the things in the afternoon session where you can see that the entire vehicle with the GPS GIS data is being tested in. Okay, and as far as gaming industry is concerned, you might be a big fan of PUBG, or it might be any other uh, what is called as gaming. Say we have Google DeepMinds. So do check the website called as Google DeepMinds. They have wonderful content there in terms of if you're planning for your research. There is a collaborative work where you are a startup. You can obviously approach them. They will help you out in terms of funding, in terms of licensing of various uh, say licenses associated to some commercial licenses you want in, or you may require certain libraries. They would assist you. So in terms of AI in gaming industry, Google DeepMind basically has a game called as Alpha Game, and they had used AI to play chess. This is not the normal chess which we play in. This is called as AlphaGo. So on the right side, you can see that this is a Chinese chess, okay, which is very difficult. The grandmaster was defeated by an robot. Okay, so you can imagine in like how advanced we are in terms of artificial intelligence. Now, These are main things which I want you to note down. So what is meant by AI? AI is the intelligence exhibited by machine and is based on the premise that intelligence is not real or human, where it would be mimicking what is called as cognitive function that exhibits or that is exhibited by humans. So whenever you talk about artificial intelligence are basically in three stages. The first stage is called as artificial narrow intelligence. The second stage is called as artificial general intelligence. And the third stage is called as artificial super intelligence. So ANI, which we also call it as artificial narrow intelligence, which came to market in the year 2015. Currently, we are here, that is in artificial general intelligence, that is 2020, where we talk about artificial general intelligence. So in the year ASI, which we call it as artificial super intelligence, the machines would surpass what is called as human intelligence. Okay, so this is where when you see that most of the technology uh, would be having what is called as super agents, which would surpass human technology. They would be experts in each and every domain. Okay, so these are the three stages of AI. Okay, so when we talk about the three stages, okay, so whenever we talk about artificial narrow intelligence, it's basically was started in the year 2015, where you are using big data driven systems for machine learning. When we talk about artificial general intelligence, the advanced network training, basically in terms of ad hoc systems to improve themselves using data. And as far as artificial superintelligence is concerned, it is having machine consciousness and system characterization in terms of cognitive self learning. Okay, so as far as the introduction is concerned, artificial intelligence would impact all the segments of our daily life by 2025, and it would have huge implications in the range of industries such as transportation, logistics, healthcare, home maintenance, and customer services. Now, on the right corner, you can see that artificial intelligence, okay, this is the general representation of how artificial intelligence is related to machine learning and then related to deep learning. Okay, so whenever you talk about artificial intelligence, it is any technique that enables computers to mimic what is called as human intelligence based on certain set of rules. These set of rules based would be based on machine learning algorithms or based on deep learning algorithms or your neural network and fuzzy based algorithms. Okay, so what is machine learning then? Machine learning is a subset of AI. Okay, so whenever you talk about a Venn diagram, okay, the artificial intelligence is the outer ring, and then the machine learning would be a subset of it, which includes statistical techniques that enables machines to improve its task. And basically, they categorized as deep learning. And whenever you talk about deep learning is a subset of machine learning, and it composes of algorithms where the feature extraction, okay, in terms of machine learning, you have to identify the dominant features and then feed the data in, right? So whereas in deep learning, there will be a layers of convolutional neural network layers. When you pass the set of data through these convolutional layers, it might be an image signal, right? So it extracts the dominant features by itself. Okay, so whenever you are training the algorithms, you require high-end platforms which can make the AI algorithms work efficiently and accurately. Okay, so that's where we talk about platforms like GPUs, which are from NVIDIA Jetson, or it might be Xilinx platform, that's your ultra scale platforms, which are out there currently in market. So what is meant by data analytics then? So observe here, whenever you talk about data analytics, imagine you are having a large set of data. Okay, and once you have this corresponding set of data, okay, you would be analyzing that corresponding data. So as a data scientist, if there is a set of data, you should be asking what is called as right questions, and that question would be like, what happened? Okay, and then why did it happen? What will happen? And then what should I do? These are the right questions. As a data scientist, when he's trying to analyze his data, he should ask right and precise questions, which is called as analytics. So whenever you talk about data analytics, it is basically derived or summed as d square p square. So whenever you're trying to analyze a data, describe what the problem statement is all about, and then diagonalize your data, right? Okay, which completes your d square, and then p square stands for predict. Okay, so what has based on the diagnosis you predict, and then you would be able to prescribe, right? So it is basically the predictive, right? Now whenever you talk about these things, there is human intervention also, which would be resulting in specific decisions and the corresponding action. So whenever I go and train students, I generally take an analogy of a doctor and patient. So imagine there is a patient who goes to the doctor, okay, and then imagine he is having fever, and then he goes to the doctor, and doctor will he directly say that okay, you have COVID, you get admitted? No, right? So what he does, the doctor would generally say that okay, you are having fever. He would just say okay, he would ask you the right questions or try to analyze the data. So he'll say okay, from how many days you have fever? Did you take any medicine? Okay, morning do you have fever, or in the evening you have the fever? Do you have shivering? Do you have headache? So such kind of questions he'll be asking you. So he'll be describing, okay, and then based on which he'll ask you to lie down. He checks your blood pressure, checks your heartbeats, and then he feels that okay, you have to undergo some blood tests. He'll ask you to undergo some blood tests. Basically he'll be diagnosing what has happened. Okay, and once your reports are out, or once he has diagnosed the patient, once the reports are out, he would say that okay, you are having this problem, right? So you are having a normal fever, which is a viral fever. So take these tablets, and let's see after a week if again it persists, right? Then we'll go ahead for the COVID testing, right? So that is where he would prescribe you specific medicines based on the diagnosis. The same thing where you have a human input, analytics performed on whatever data is there, based on which you will be able to take decisions and action, okay, is called as your data analytics. Okay, so it might be in terms of analyzing the data of a patient. Nowadays you can see that there are fit bands which are available, which can tell you like your accelerometer data, gyroscope data, and then tell you whether what is your blood pressure. Okay, if you hold your forefinger exactly in front of your camera, it will tell you what is your heartbeat rate, right? So what is the oxygen levels, right? So such kind of things, already we have algorithms which can where you apply the DWT, and you will also count the number of heartbeats, and based on which when you can tell that whether the person is alive or dead. Okay, so such kind of things you can see that algorithms which have been developed by using just a laptop and a camera which is out there. Okay, so as far as the components of data science is concerned, okay, so whenever you combine domain expertise and scientific methods with technology, you get what is called as data science. So you might be a domain expert. It might be from computer science engineering, mechanical engineering. I'm an electrical engineer or a VLSI engineer. So basically, you should be a domain expertise in your domain, and then you have a bunch of technology. It might be using of software like MATLAB, Python. A combination of that is nothing but data science. Okay, so you use the statistical and mathematical modeling, and based on which you arrive at certain business solutions. Okay, which influences the business insight and also predicts the business solutions, which can be in terms of increasing the revenue or decreasing the overall cost or overhead, and then increasing the profit margin. Okay, so like that, if you are using a combination of domain expertise and scientific methods with technology, you will be getting what is called as data science. So as far as the role of data scientist is concerned, you would be having a set of data set. Okay, as we all know, as a data scientist, you should be asking the right question to acquire the data, wrangle the data. Okay, so whenever you download the data from a cloud, or you are capturing the data from your mobile phone, or it might be data from a website. When you download the data during certain uh, download procedure, or when you're transmitting the data, there might be some amount of data which is missing in, right? Or there might be some amount of data which is say having some noise. So as a data scientist, 70% of your time you would be spending here in terms of data wrangling, and then based on which you'll be applying mathematics and statistical model, visualize the data, and then generate data reports associated to whatever models which you have in. Okay, so this is one of the important terms when you look into what is called as uh, data reporting, and then you should be able to apply the data products on whatever algorithms which you have developed in. These data products would be manufactured by you by applying what is called as the machine learning algorithms on it. Okay, so as far as the demand for data scientists are concerned, there is a wonderful article by Andrew Dean. So he says, he talks about why data scientists should be one of the most promising careers by 2020. And there would be a lot of demand in terms of data scientists, because you can see currently in industry, almost around 15,000 plus jobs are vacant only in Bangalore. Okay, so here and then, like if you are just working as a faculty also, like we see that a lot of faculties who complete their uh, PhD in computer science, especially in the area of AI and ML, they generally switch to say corporate, right? So the reason for that is that the data scientists, uh, the job opportunities are more, and in terms of salary also it is very high. And this is not being projected by me. This has been projected by Forbes, and these are few of the what is called as websites which you can look into, where you would be able to find more details about the demand for data scientists growing up every year. So whenever you talk about big data analytics flow, okay, so this is what is called as a big data analytics flow. Now imagine there is huge data set. I can take an example of you using Ola or Uber, right? So when you enter that you're traveling from Electronic City to Hyderabad, okay, which is an outstation cab, it actually checks the pricing and tells you like it is this amount of kilometers, and it projects you the pricing also. So how does that happen? That happen because of what is called as there is data set, which is in terms of a lot of large set of files which are out there, and which you can load it into this what is called as your file formats to your software. These data sets can be from sensors also. Okay, so once your data set is being accessed or file is being accessed, say for example, if I talk about Bangalore city only, if I take 1 data, it would be more than 2 GB. Okay, so imagine you are using Python or you are using MATLAB to import that software into, or import that data, that large amount of data into your system. It would be a tedious task, right? So the same thing is called as access and explore your data. Once the data is being accessed, as I said, there would be some amount of missing data or noise present in it. So you pre-process the data. So if there is a messy data, you remove those messy data. If there is a missing data, you either fill that missing data by taking standard deviation or inserting the mean values there, okay, or directly deleting the values which are, or deleting the row or column which where there is a null data, because that would influence the accuracy of my machine learning model. Okay, that is called as data reduction and transformation. And then whichever data set which I download, it will be having some amount of dominant features. Okay, so in MATLAB there are functions which you can use in where you can identify or extract dominant features also in MATLAB, or there are different methods also. Okay, so as we go further, we'll discuss on that also. And then we have developed models or predictive models where you can predict what is called as model creation in terms of machine learning, optimize whatever model you have created in, it is called as parameter optimization, and then finally you'll be able to validate that corresponding model. Okay, so this entire process is called as development predictive models. And the last process is that you can deploy these algorithms on hardwares. Like if you talk about a cluster which is there in your college where your website is running in, you can directly deploy on it so that your algorithm gives you highest accuracy, right? So you can use MATLAB, Excel, C, C++, Java.dll, and then you can deploy those algorithms on these embedded devices and hardware. Okay. So this is one of the small example where we can see that there is Volvo vehicle which was developed, and this is a self-driving video, and which I think this would be relevant in terms of talking about self-driving cars.
Hello, Pramod here. Hello. Hello.
Hello.
Pramod here, no audio is coming.
Hello.
Hello, Pramod here.
Yeah, sir. Yeah.
No audio, only video is playing.
Okay. 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 I'll just try to explain when the video comes in there.
Okay.
Yeah. So as far as data access is concerned and pre-processing challenges are concerned, you can see that 80% of the time is being spent by what is called as data access and pre-processing challenge. 80% of the time is being spent in terms of data refining. Okay, so whatever the data cleaning is there, you can see that you aggregate the data from different sources, or you would be receiving the data in different file formats, which is an image, audio, text, Excel sheet, and then you would be able to clean that data. Okay, so whenever you're trying to clean that data, whatever we talk about in terms of data pre-processing, it would take somewhere around 80% of your time. Okay, where the data would be sometimes poorly formatted. It might be in terms of irregularly sampled data, or it might be something called as redundant data, or there might be outlier. Now, what is meant by an outlier is, say, you're trying to calculate average salary of faculty who are working in a college. Okay, and then based on the average salary, you're trying to allocate what is called as bonus. But imagine in the same college, you also have Ambani working as a professor, right? His salary is very huge. Now, if you're taking adding him up and then taking the average of salary Okay, and then you would be allocating what is called as bonus to the faculty. That's your Diwali bonus if you're planning it. So no one would get a what is called as bonus because there is an outlier, right? So the salary of Ambani should be kept aside, which is an outlier, and then as a data scientist you should be able to identify that also. So that is where data visualization plays a vital role in terms of outliers. So you have to identify, is there any outlier available in my data set, because that would influence in whatever machine learning algorithm which I built in. Okay, and then there are specific processing which might be in terms of signal smoothing, resampling, or if you're working with images, there are different processing steps which we generally follow in. And then how to deal with out of memory options also. So whenever you are having large amount of data, so how exactly you would be able to deal with such kind of data. So in MATLAB there is an concept of tall array, and then a concept of MTCS, okay, and pipelining and parallel processing, which you can use in, and then you would be able to process that data on a real-time scenario. Okay, so data preparation accounts about 80% of the work in terms of what is called as data pre-processing. Okay, now to start off with our session in terms of hands-on, let's go into Internet of Things. First step is first, how do you access or how do you assess or access or extract data from sensors, or it might be from what is called as uh, a web page or various things. But in the meanwhile, we'll also discuss about Internet of Things. And then once we discuss about it, we would be switching towards different websites like Kaggle. We have different government websites where you'll be able to download the data set. So all those things we would be discussing as we uh, go further with our session. So now whenever you talk about Internet of Things, okay, basically we have multiple devices or sensors which are connected to a controller, okay, which is called as gateway. And via gateway these devices are directly connected to internet, where you can directly connect these devices or you can virtually connect them, where you are actually transmitting large amount of data, or there is an information exchange happening between the devices. And then connecting these devices directly to internet basically would replace the manual entry of whatever data which you're trying to do, and that would increase the automation process in industry or any kind of application which you're trying to build in. Okay, so what is a simple example for IoT? Now say for example, when I ask like, have you worked on IoT or have you used IoT, the general question would be, sir, no. Now, if you look into this website, you can see here, I'm entering two different locations here. I'm traveling from Electronic City to one of the college, and then it tells me like, okay, this is the route which would be the fastest one, and this is the time duration it would take. 2 hours, 8 minutes is the time duration which it will take to reach that corresponding destination. Okay. Now, what is meant by Internet of Things? Now, as we discussed, there are different sensors, like I might be having a temperature, humidity, pressure sensor, which have been placed, say it might be in US, UK, okay, which have been connected to what is called as gateways. Okay, so there would be gateways. So these would be having small ICs like ESP8266, which is your Wi-Fi module, or these days smaller controllers like Raspberry Pi, which is a SoC, which already comes with an inbuilt what is called as Wi-Fi module, or you can have a FPGA to which you can connect the Wi-Fi module, and then connect different sensors, which we also call it as P mods, and then transmit that live data. Okay, so whatever data is there, that data can be directly transmitted to the cloud. Okay, which is basically uh, collecting the entire data. And then once the data is being collected in, you might be having an app or a website or a channel, okay, through which you would be analyzing the data. Okay, and then once you analyze the data, that entire process of analyzing data is called as your exploratory data analysis. and then you would deploy different algorithms on the nodes for a specific application, right? Say for example, you're trying to count the number of vehicles, okay, and on the left side of the lane and then on the right side of the lane. So if the number of vehicles on the left side of the lane is more, so you would turn the signal as green and allow those vehicles to move out first, and then where the number of vehicles are less, that signal would turn on as green later. Okay, so like that you can build different kinds of application. This is one of the things which we did it in Mangalore, and where we had different gateways, we had cameras connected to it, we had a small Raspberry Pi unit, and then via that we were able to segregate the data, count the number of vehicles, and then we integrated it to the website. How did we do that? So let me just switch. We have a lot of theory, so let me just switch to MATLAB here. Okay, and in MATLAB, okay, let me take 1 minute to explain MATLAB, and then I'll switch to one website also. Okay, now whenever you double click on MATLAB, you can see that this is my generalized GUI of MATLAB. You have different tabs here. One is called as your home tab, the second is your plots tab, third is your apps, you have the live editor, and then you have different insert options, and then in the view you can set up the different view options here. Now whenever you come to the home tab, basically everyone is aware of it. MATLAB basically has a current folder, so whatever programs I write in, it will be there here in the current folder. Okay, and then there are different file formats which are out there in MATLAB. We have file format like MEX, MLX, LiveScript, .m, right, SLX, MDL, right, if you're working with Simulink. So those are the file formats, right? So we'll take the programming, or we do the programming in MATLAB by just pressing Control N. Okay, so you can see that it opens up a new file which is called as editor window. So whatever programs I write here, you will be able to edit it, and then whatever commands I want to give to MATLAB, it will be basically given in the command window. Or if there's a specific program I want to run, I can just go ahead and type the name of the command or a function which I want to execute here. Okay, so whatever variables we create in, it will be basically in the workspace. Okay, so let me not discuss on the basics of MATLAB, but let me just take you further. I hope everyone who is attending the session has already worked on it. I assume that. Now what we would be doing is that, okay, look here. Now we have something called as an website called as ThinkSpeak. Okay, and let me just take you there. Right, so this is the website called as ThinkSpeak. Okay, so this is where you can go ahead and create a MathWorks account, and then you can get the licensing for free, where you can check the air quality monitoring. So this is what we'll be doing in. So there is an air quality there is a setup from which sensors will be collecting the live data from Boston, and we'll try to analyze that data. Okay, so it might be in terms of energy monitoring or smart farming. So you would be able to collect, analyze, and act. You can also go ahead with MATLAB, Arduino, ESP8266, Raspberry Pi. You can integrate with it, and then also you can do app integration also. So how to do that? Let's go ahead and check it. So in the meanwhile, let me just share this particular, where is the chat? Yeah, so I'm just giving you that website. Yeah, so this is where you can just go to thinkspeak.com, and then once you create an account, on the right corner you can see that it'll ask you your email ID. Enter your email ID, enter the password, and then sign in. Right, so you can see that you have signed in into the website. That's your channel, that's your ThinkSpeak. Okay, now here you can see that there are different channels. Okay, so already I have created 3 channels, so I'll not be able to create different channels here. So what I can do is that I can go ahead and then create a new channel. Say for example, you have a Arduino board, you are capturing the live data from the Arduino board and writing the data into the cloud. For that, you can just go here and then click on new channel. Okay, and then you can just label the new channel name, give description, you are measuring something called as TEMP. You're trying to measure temperature, humidity, and then pressure. Okay, so you can measure that, and then you can tag it to your college website also. So for example, in your college, you are trying to see if there are any lights which are turned on, so you can connect a thermostat and then a transducer and a light sensor. If there is light emitting in that room, the bulb has to automatically switch off. So such kind of things, if you want to do, or manually you want to, with a click of button, the entire switches or the lights and fans in the college has to turn off. So such kind of things you can do it. Or you can also link it to an external site. Like you can just say that I want to visualize the location in terms of latitude and longitude. And if there are cameras, like you have taken a Raspberry Pi and then you are streaming the live video, you can also stream it to YouTube or Vimeo. Okay, or you want it to be specifically for your college website, you can directly stream it, and then you can just say save channel. Okay, now once you say save channel, okay, it would come down to channel like this. Okay, and then in these channels you would be able to have different options here. Okay, now once your channel is being created in, you can go to the first option here. Okay, where you can see that the channel says private. Okay, so whatever data set is there, you can load that data set here. Okay, so you have said temperature monitoring. Okay, and then you say location, and then you have added up different cages there, right? And you can make the channel to be viewed by specific people. So you can just go ahead and click on sharing and then enter their email ID here, right? And if you don't want, you can keep it as public only, but at that time you would be requiring the channel ID. If I post the letter, it has to reach you, right? So each data set, when you're trying to send it to a cloud, you should be very clear that what is the address of your channel. Okay, so this is one thing which you require in, and then you would be requiring the API keys. Okay, so basically when you talk about API keys, these are the keys which are having the read and write. So whenever you want the data to be written from the cloud to these channels, you would be requiring the API keys which has to be mentioned in your program. That is, first thing is the ID, and then if you want to write that particular data, you require write API. If you want to read the data from the cloud, you would require read API key. Say for example, if the channel is somewhere in US, okay, and then you want to read that data here in India, you would require the read API keys. Okay, and under channel settings there are different things here. Okay, so we had shown you all this, right? So you can link it even to your GitHub page also. Okay, so you would be having a GitHub account, right? To that you can connect it. Now once that is being done, you can also in terms of sharing, I have already shown you API keys I have mentioned, and then you have data export and import. So if you have a CSV file format, you can directly choose that file and then import it, or whatever data set it has captured. Okay, you can directly export that corresponding data. Okay, now as we said, API keys here. So first thing is your channel ID, author name, the access is private. I have not made it as public, but there will be certain set of channels which would be public also. So where do I see that is, I can just go into channels and then I can just say public channels. So in our first model, what we'll be doing is that we would be taking any one public channel. So you can see that there is one public channel here with channel ID 935349. ThinkSpeak app is also there where you can directly capture the data live on your mobile phone also. So if I go here and then click on this channel, you can see that it is capturing the dust on live, the dust concentration in last 3 days, and then the temperature in last 3 days. So it is from 32 to 34 degrees centigrade. Humidity is there, okay, and the pressure is there. Okay, and then you have a fish tank sensor, which where it is trying to measure humidity, pressure, and then the dust concentration. If the dust concentration is high, then obviously you have to go ahead and then change the water in that corresponding tank. Interesting, right? So such kind of things you can build in. So one such kind of application, what we'll be doing right now is we'll be taking MATLAB. Okay, so you have mentioned the channel ID here. And let me be very clear, when you're running the set of program, I'll share you this program after the session. So do not worry about it. Let me just explain the program completely. If I zoom in, is my screen visible? I hope it is. If it is not, please let me know. So in the first thing is that my intention here is that there is a weather station. Okay, or you know that there is Boston with US, there is a weather which we are trying to monitor here in Bangalore. Okay, and then I'm displaying the results to you guys who are sitting in Hyderabad, Telangana, Karnataka, right? So first thing is that I'm mentioning the channel ID. So channel ID of the ThinkSpeak account is 213451 and the read API key. So there is already data which has been loaded by a microcontroller into the cloud. Okay, and then I'm mentioning the time and date. So I have date 1 where I say the year and then I say the timing, and then I say day 2, the year and the timing, and the from which time to which time I want the data that I have mentioned. Okay, then I'm passing or I'm creating a table. Okay, so I'm creating a table T where I'm telling that, okay, ThinkSpeak read, I want the channel ID. This is the channel ID. Under fields, I want 1 to 8. So there are 8 fields like temperature, humidity, pressure. So there are different fields in that. So from that channels, I'm capturing the live data and then I'm mentioning the range. Okay, so range of D1 and D2. What is D1 and D2 you have defined? D1 and D2 is nothing but the time duration. After that, you are telling that the output format should be in terms of not a table format, it should be in terms of a timetable format. So I want the time also playing a vital role, okay, in whatever model which I generally work with. Okay, and then I have an option where I can go ahead and then I can mention the read keys of whatever channel which I have written. Okay, so I hope this part of the section of the code is easy. Whenever you are running this, see into that there is internet here. Okay, and let me just go into the editor here, and instead of running the entire program, I'll explain step by step and then we would read the data. So it is taking time. You can see it is busy here. It is reading the channel. There is read key. I have also mentioned D1 and D2, and then I'm capturing the data of various fields. Okay, that is T. Now you can see that the value is out there. Okay, and then I can just come here and then say T. Okay, and then I can press enter. So now you can see within couple of seconds it captured this large amount of data via internet, where it has captured the analog data, it has captured light, sound, humidity, heat index, pressure, altitude, and temperature LPS. So basically it has an analog sensor as well as digital sensors to measure the temperature. Okay, now once it has measured that corresponding data, so this kind of data I take and then I apply machine learning. Okay, so that also I'll just show you. Now once this is being done, I want to plot that data. So what I can do, I can just use 2 lines of code and then I can just run this part of the section. Now it would plot that corresponding thing in terms of a graph. Right, so you can see it has projected it. Now what I'll say that I want to visualize my data, and for that I'll say that I is incrementing 1:8. Whatever the data set is there, okay, the light, humidity, pressure, heat index, I want to plot them as a subplot. So it is 4 comma 2 comma 1. So it will be like a column wise plots which I want in. And what is the value of I here? 1 to 8. So 1, 2, 3, 4, 5, 6, 7, 8 graphs I have to plot, where the grid should be on, and along the X limit, it has to increment from the first till the last value. Okay, so when you said here sum head of T, it gave you only the top 8 values, right? And then when you just saw T was very huge here, right? So, right now in that, I want to visualize what is called as the data. So if I go here and then run this, it would plot me all those data, because me visualizing this data and analyzing the data would be very tedious. So I think by now I have got that graph, where you can see that this is 1, 2, 3, 4, 5, 6, 7, 8 graphs. Okay, now this is the analog temperature, where at 12 o'clock to 4 o'clock there was a lot of fluctuation of temperature between 18 degrees centigrade to 24 degrees centigrade. And when the temperature is varying, you can see obviously there is a change in my humidity also. And since humidity changes in the heat index and the pressure, there is variation. And at the same time, look into the altitude as well as the temperature. In terms of digital also, there are similar changes here. Okay, and observe the light. So light index also is varying here. Okay, so this is from the live data from Boston. You can mention the timestamp, and then you would be able to capture that data. And then once this is being done, I plot that corresponding data, okay, in terms of a timestamp. So both analog and digital sample data is being combined, and you are able to get the output here. Now, once this is being done, my intention is to identify noise pollution there. Okay, so for that, I'll do sound is equal to smooth data. So whatever that T dot sound is there. So if there is a table, if I want to take a specific set of data, I can write it as T dot sound, that is structure. Okay, in structures, I can just say T dot sound from that table. Okay, from this T, whatever we just saw, from that you are taking only the samples of sound. And then you plot that samples of sound with a line width of 4. Okay, and which has the highest sound peaks, you are trying to determine the numbers there. So let's go ahead and run that part of the code. So you can see this is how the sound sample. So whatever you captured here, this is from the sound sensor. You have mentioned the line width of 4. That line width, you can see it is very high. So that indicates that this is how the sound is varying there. It might be because of vehicles or some other condition. Now, once that is being done, I want to find out the peaks. Okay, so out of those peaks, I'll use a inbuilt function in MATLAB, which is called as peak find. And the syntax for that is that you enter the variable name. So the variable name is sound. In that minimum peaks, okay, you're finding out which is more than this. And then you say the minimum peak width is just 10. Now, if I run this, you can see here it would be able to tell you which are the highest peaks. So you have said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 peaks are there. So that value would also be displayed here. Right? So I want to calculate the 12 peaks now. For that, I'll say P is equal to find peaks in the sound variable. In that find peaks, display the amount of peaks, where you convert the num to string, and then you take the length of that corresponding data. Now, if I run that, it has to tell me that the number of peaks was how much? The number of peaks was 12. So like this, you can also calculate the number of peaks in terms of sound. Is it as? Okay, so this is how you have a cloud account. You can go ahead and then mention what is called as the channel ID, you require different things, and then you can also perform MATLAB analysis, MATLAB visualization also. Followed by that, you can also link it into your Twitter think tweet, right? So you can also connect it, like say for example, morning, I generally get up at somewhere around 6:30, and then by 7:30 I have my bath, and then I go to office. Generally what happens is that by mistake I forget to switch off the geyser, right? So by 9 o'clock, okay, if the geyser is on, you can imagine in the situation, right? So instead of that, I have created an condition where you get these Wi-Fi switches available in Amazon. You create a Wi-Fi network where you can just say after 8 o'clock, if your geyser switch is on, automatically you get a call or a Twitter message stating that, hi bro. Okay, what does that mean? For me is that I have not turned off the geyser. So you can customize this, which is called as time control. You can link it to your Twitter account where you can generate the API keys, or you have options like where you can say time control. Okay, so where whatever the machine learning algorithms which gives you a conditionality, you can create a time control there. And then you can also go ahead and react. So you want some operations to be reacted in. So you can act on data. You can go ahead and then act on that specific data set, whatever you have. Okay, you can also have talkbacks, like we have Google Siri, or it might be apps which are generally using it. So you can also have a new talkback. Just go here and then you can set the name of the device, API keys, and log to the channel. Basically you can also create a talkback application. Afternoon session will create a talkback. Okay, so this is with respect to what is called as the IoT part of it. Okay, now as we discussed, there was a sensor which was placed. It has been loaded into the ThinkSpeak account. Via ThinkSpeak account, we captured that data here, and then we have done the processing of it. Okay, now IoT solutions can be of different types. If you're not comfortable with programming, you can also go ahead and develop applications like this, where you have different sensors which are being connected to the edge nodes, and via the edge nodes you would be able to write that data into the cloud. Okay, and then you would be able to analyze that data, okay, in the ThinkSpeak account, read the data and perform historical analysis and also algorithm development for processing that data on real time. Okay, now what we did was we did weather monitoring, and basically there would be a set of Arduino board, okay, Arduino mega board, where you can see there are multiple sensors, like the wind direction we saw, humidity, there is a DHT11 sensor here, then we have the pressure sensors, P modes are there, right? So these are different sensors which was capturing analog sound, light, humidity, pressure, heat index, altitude, okay, and sound. Okay, so these were the different parameters it was capturing in, and then that what is setup was placed somewhere in US, and then you would be able to analyze or extract that data and process that data, also visualize that in multiple systems. Okay, we also talked about weather monitoring, where you can link it to a Twitter account, say that today if it is raining in, you can just have a similar kind of setup, and if there is probability of it, there is a rain, or if there is a probability of some X condition, whether there is cyclone or such kind of Twitter linking conditions, you can just connect it to your mobile phone. Okay, so this is how the setup would look like. Okay, we have come up with an advanced board which looks similar to this, but it is far advanced. Okay, the size of that is very big compared to this, where you have multiple sensors on the board itself. Okay, so you need not do any wiring and all, where you can directly connect these boards, and then you can transmit the live data and then receive the live data also. So it have these sensor modules in it, and then you can monitor that data on real time and then process that data on real time. Okay, so any questions associated to ThinkSpeak, I would be going to my chat box now. If there is anything, you can just put it there. I would be happy to address that. Or else we'll move ahead with machine learning. Are there any questions? Are there any questions? If it is not, if there are any questions, I'll give you 30 more seconds. Okay, see, DHT sensor, whenever you are trying to measure humidity, pressure, like we have sensors like DHT11 and DHT22, which measures temperature, humidity, and pressure sensor. And then as far as the sound sensors are concerned, there are different sensors which you get in. And then there is TMP36, which can directly measure you the temperature in terms of degree centigrade. Okay, and then there are multiple sensors, like if you go into what is called as in India, if you want to purchase it, what is it? Okay, I'll come to this one by one. Yeah, so see, ML algorithms cannot be I mean, see, sensors basically will be getting the data sheet. So if you have any specific sensor, like vibration sensors are there, or it might be what is called as 2016 LPF sensors are there, which can measure what is called as gaseous of different kinds. So such kind of sensors, if you have any specific requirement, you can obviously reach out to me. My phone, you can reach out to Ramesh Naidu. I think he'll connect it to me. Okay, and I think we'll customize the sensors and we can give it to you. Okay, so there is no problem with that. And can you elaborate the procedure of deploying ML in any embedded platform? See, embedded platform, we can deploy the algorithm like on FPGAs or ARM platforms or GPUs. You cannot implement it on a Arduino board. Okay, Arduino board for capturing live data and writing it into the cloud, but as far as deploying it on an Arduino, it is not possible. But as far as Raspberry Pi is concerned, we would be doing that in our second set of sessions. So whatever say deep learning algorithms like ResNet, say Inception 50, okay, so that we have in our second set. Not only Raspberry Pi, we'll do it with NVIDIA Jetson Nano also. Okay, so what is the issue? Okay, there is one more thing which has been added up here. Can you specify which tools are used for this purpose? See, whenever you are trying to deploy the algorithm on Raspberry Pi, say you can program the Raspberry Pi using C, C++, or embedded C, right? So basically, in MATLAB, there are coder products. Okay, the first thing is that for development, you require MATLAB. And if you have developed the algorithm in Simulink, you require Simulink. Then you are developing machine learning. So that's a prerequisite, statistics and machine learning. And then you would require deep learning toolbox. So these are set of toolbox. And then if you're working with signal processing, you require signal processing toolbox. If you're working with image processing toolbox. How do I check that in my system? Is just go here and type VAR. It will give you the license detail as well as a list of toolboxes. Say, for example, if I'm working with OCR, optical character recognition, or NLP, this toolbox also would be required. If I'm working with ADAS, okay, so ADAS automatic driving assistance toolbox is required. So like that, there would be different toolboxes which you require. Okay, and once that is being done in MATLAB, there are coder products where you need not write any C, C++ code to deploy the algorithm. MATLAB takes care of generating the code and then deploy the algorithms on FPGA where it generates Verilog or VHDL code. So that time HDL coder and verifier is required. If you want to put it on a Raspberry Pi, you require embedded coder. And then if you want to put it on a PLC, you require a PLC coder. And then if you want to put it on a GPU, you require a GPU coder. So those are the products which you require. Sir, what is the issue associated to real-time video processing and decision-making using machine learning in case of application of self-driving cars? See, one such project which we were working was in terms of synergizing the various sensor data and the computer vision data. Okay, there are a lot of problems associated to it. What happens is that whenever you talk about self-driving cars, there are different sensors like lidar, radar, and computer vision data. When you try to sync them together, there are a lot of issues with it. Okay, so that is where now we also have something called as new toolboxes which have been added up to MATLAB, and that can be addressed as we go further. We have demos on that. Okay, stay tuned. We have those demos in the afternoon. Okay, I'll show you those. Okay, so like this, you will get the list of toolboxes. Now let me just clear it. And give me 1 minute. Okay, so everyone note this command, Fisher table. Thank you everyone. When you ask questions, we also feel lively and we address the questions. Yeah, so just note down Fisher table, read table, Fisher iris.csv. Okay, so this is one of the data set which we'll be loading in MATLAB. So this is an inbuilt data set which we'll use, and then we would be switching to machine learning. Okay, so every time, every session would be on different OTT platforms. So I forget where is the chat window. Yeah, so this is the command. Everyone, please make a note of it. Fisher table iris.csv, and let me just close this. I mean, let it be, no issues. So don't require this. Yeah. So let me take another 1 hour on machine learning. Okay, we would be doing a lot of hands-on now, and then we'll also discuss what is meant by machine learning, and if time permits, we'll also load certain set of data. And in the afternoon, as we go to deep learning, we'll also talk about self-driving aspects and an example on self-driving cars also. Okay, so thank you everyone. Let's go further from here. So what is machine learning? So whenever you talk about machine learning, okay, so there are different statistical and mathematical models which you generally see in. Okay, as we discussed, there are different machine learning algorithms which are being developed by a set of engineers and scientists working across the globe. Okay, now if you are using Python also, you have to install certain set of libraries. You have to install certain set of libraries in MATLAB, and then once you have installed those set of libraries, you can directly invoke those functions. So what does this X mean is basically you would be basically a domain expert, and once you are a domain expert, a combination of machine learning and domain expertise would help you in developing these models. Okay, now once this is being done, what is the domain expertise here? So as far as machine learning is concerned, machine learning basically would include a set of say your domain expertise, like your industry knowledge, your application knowledge, and your own expertise. So uh, a mechanical engineer, if he is trying to analyze the sales of vehicles, okay, and then he has to identify his right customers whom he can go and position his vehicles, like it might be based on the salary of employees of an X company. So he collects the data set, and then he identifies who are my right uh, people whom I can approach, and based on that I would be able to uh, process the data and acquire the data on real time. Okay, so such kind of things you would be able to do that in what is called as MATLAB. Okay, now as far as the industry knowledge is concerned and application knowledge is concerned and your own domain expertise is concerned, a combination of this, you would be able to develop what is called as machine learning algorithm. So you can do it using apps, you can do it with auto ML. Okay, and then you will be able to generate what is called as C++, and then deploy the algorithms on hardware of your choice. Okay, so as far as machine learning is concerned, it can be your domain expertise where you are trying to analyze what is called as uh, what is called as uh, fleet data analysis, or it might be in terms of manufacturing analytics, signal processing, energy forecasting, and then application knowledge. Okay, so such kind of things you would be able to uh, have something called as energy forecasting, and then it might be having an application in terms of medical devices and data mining. So how as a person you would be able to analyze this data is what you would be able to generate machine learning algorithms is what we'll be just checking it. So whenever you talk about machine learning basically uses data and then it produces a program to perform a specific task. So where do I get data from? Right? So that would be the first question. So what we'll do is, let me just come down here. Oops. Okay, so okay, you can just go here. Okay, so this is one of the place where you will get ample amount of data set. Okay, so it might be in terms of movie predictions, or it might be in terms of Indian food, it might be in terms of trip advisory, it might be in terms of COVID impact on air traffic, right? So such kind of data set, you can just take it here. Are there any polling which is going on?
Yes, Pramod garu.
Okay, fine, sir.
Yeah, myself kept it. Okay, you can. Yes, sir, no problem. You can minimize that poll.
Okay. Yeah, so this is where you would be able to get wide variety of data. Okay, so this is another website which you can look into. Okay, and then there is data.gov, and there are different websites which you can go here. And, yeah. So okay, so this is one of the website which you can obviously visit in, and similar to that, I have few more bookmarks here. Let me just share it. Where is that UCI? Yeah. So this is another website. Okay, so when you type that fisher.iris.csv, so that is basically a data set which was created by RA Fisher. Okay, which has somewhere around 150 instances. So there are different set of flowers, that is Setosa, versicolor, and virginica. So they plug these flowers, and then they have measured the sepal length, sepal width, petal length, and petal width. Okay, and then stored it inside a Excel sheet. You can just load it as a mat file format also. Now we used Fisher table.iris.csv and then loaded that in terms of a table format. Okay, so this is how the fisher.iris.csv dataset would look like, and from here you can download the dataset, whatever, if you're working with Python, or if you're using with MATLAB. So Python also will just show you in our next webinar series. If I just remove this, okay, if I come down here, okay, and here you can see ample of data set again. Okay, so these are where you would be able to capture the data associated to cancer, heart disease, wine, car evaluation, or it might be in terms of forest fire, right, student performance, and so on. So this, like this, there are different websites which you can go in, and if you go ahead and then click on the right corner, view all data set, you would be able to see the entire data set. So you can see for clustering, classification, text, okay, life science. So like that, there are a lot of data set which is out here, which you can download and then start working on it. Okay, so this is with respect to what is called as the data set which you generally get it. Now, once this is being done, let me just close this and let me just come down here, right? So we know where we have received the data from. Okay, so when we discussed machine learning uses data, and then we know where to get the data from now. Or if you are using your own ADCs and then capturing the data, you can use that data also and then apply machine learning on it. Okay, so basically machine learning uses data and then produces what? Produces a program to perform a specific task. So if I'm talking about image category recognition, so I can do it in two methods. Like when I was using MATLAB in 2007, okay, where you have to identify, say, different kinds of images used to extract features, and based on the comparison of the features, used to say that whether it's a boat, mug, or a hat, where you should write a lot of for loops, if condition, for conditions, and so on. Okay, the same thing if you are using a combination of computer vision and then machine learning algorithm, a combination of computer vision as well as machine learning algorithms, you would be able to classify the images as boats, mugs, and hat on a real-time scenario, which is basically a combination of machine learning which uses data, that is your images are your data, and then produces a program, okay, to perform a specific task of classifying that this set of image belongs to boat, or this is a boat, this is a mug, and this is a what is called as hat. Okay, now under machine learning there are two different types. Okay, one is called as supervised learning, the other is called as unsupervised learning. Okay, so whenever you are having a data set where you are having supervised kind of machine learning algorithm, when do you apply that is, say that you are taking class to your students, okay, and then once the class is completed, okay, once the classes are completed, what would happen is that once the classes are completed, you know what you have taught, you know students what they have learned, right? You know the input as well as you know the output. So whenever there is input as well as output, say for example your flower data which you have loaded, it had sepal length, sepal width, petal length, and petal width, and it also knows that it has to get classified as three set of flowers, right? So that kind of algorithm is called as supervised learning, where you will be having classification as well as regression categories in those supervised learning. And then what is meant by unsupervised learning? In unsupervised learning, what happens is that you will be having only set of inputs. So using only sepal length, sepal width, okay, petal length and petal width, you have to group the flowers based on its common features, right? You don't have the outputs which are being named, right? So you may group this as category 1, category 2 based on its common features, which is called as clustering. Okay, so let me just take another 30 seconds to discuss on classification, regression, and clustering. So what happens in classification? Classification basically deals with data where the output would be in terms of classes, whether it is true or false, whether the set of data is setosa, versicolor, or virginica, or the classification has to happen as red, green, and blue. Similarly, in case of regression, regression basically would be like what is the temperature. Like everyone uses the weather monitoring app. So tomorrow's temperature would be 34 degrees centigrade with light showers in the evening, right? So such kind of things where you have the numerical values. Like I'm planning to purchase the share price or purchase a share of Zindal, right? In MATLAB, there is an option when you click a button, there is risk management toolbox which analyzes the share market and tells you what will be the pricing, future pricing of the share market on real time. Okay, uh, so the first purchaser of MATLAB in India was BSE India. Okay, it was not an any industry, it was BSE India who had first initially purchased MATLAB. Okay, so when you talk about unsupervised learning, we have clustering, and then there is no output to find the natural groups and patterns from the input data only. So whenever there is only input, you find the natural patterns and then group them together, which is called as clustering. So under that, there are different algorithms like classification, there is supervised learning, discriminant analysis, naive Bayesian, nearest neighbor, linear regression, and then under clustering, there is K-means, hierarchy clustering, Gaussian, neural networks, and hidden Markov model also. So all these things we'll just check in. I'm sorry for that. So all these things we'll be checking in as we go further with our session. Okay, so Nilesh has a question. Can you just put it in the chat box? Okay. Nilesh sir, please put it in the chat box. So what is a classifier? So whenever you have a set of data, okay, when you project that in terms of a graph, which we call it as scatter graph, okay. Now you have extracted the features and then you plot that in terms of a graph. There is one set of data which has been represented as red. Another set of data is being represented as blue, okay, which came projected in terms of a scatter plot. The same thing, when I apply machine learning, you would be categorizing them as category 1, which belongs to red, and then category 2, which belongs to blue. So this process is called as classification. So in our case, it might be in terms of object classification or recognition. So we'll be doing both. Okay, evening we'll identify the objects also. Now we'll just classify it. Okay, now imagine you have hat, mug, and boat. Okay, these are the three set of images you have in. Now initially you would create folders of that, which we call it as training data. You will have hundreds of images stored inside one same folder. So one folder for boat, one folder for hat, one folder for mug, and one folder for mouse, laptop. So it depends on how many data set you want or how many classification of data you have, right? So once you have stored them in different folders, you need not label and what is called as mention labeling to each and every data set. So there is a training data set. From those training data set, you use different inbuilt functions in MATLAB, and then you would be able to uh, extract features from it. There are different methods also. We call it as PCA, Principal Component Analysis method, and LDA. Okay, so there are different methods which you use in to extract features, but we'll not discuss more on it. But just remember, whichever is the dominant features, you extract features from it. Okay, and then once you have extracted the dominant features, you create a learning model. And this entire model would be your classification model which you have created. So this entire phase is called as your training phase. You have a training data, extracted features, and then you created a model out of it. Similarly, whenever you take a new set of image now, and then when you pass that corresponding image through that model on real time, it should be able to tell you that this is the model of a hat, and this process is called as your classification phase. Training phase, classification phase, or training phase and testing phase. Okay. Now, so in machine learning, whenever you are trying to go for object detection recognition, you have different inbuilt feature extraction functions. Few to be named are brisk, surf, freak. Okay, so like that, there are different feature extraction functions, or then you can use histogram of gradients, bag of visual words, or color based and frequency domain custom features. You can use it. So whenever this is the input image, when you extract features, okay, you'll be able to see the handcrafted features like this, and then on that you apply machine learning algorithms like SVM, nearest neighbor, decision tree, discriminant analysis, and assembly classifiers. You apply that, and then on real time you would be able to classify that as a truck, car, SUV, or so on. Okay, so in the meanwhile, let me just come back to my MATLAB here. Okay, let me just go here and clear everything. Okay, I have given you this command, Fisher table dot read table dot CSV. I'll put a semicolon. I don't want the results to be displayed here. So you can see there is a table which is created. Now, if I want to visualize this table, I can double click on it here. Now you can see it has data associated to flowers. Sepal length, sepal width, petal length, and petal width associated to first set of flower, that is setosa. Then there is versicolor. Then you have virginica, right? So these are the three set of flowers which you have loaded with just one line of code now. Now, once this is being done, what you can do here is that you can just come down to the app section here, click on the drop down, and then there is classification learner app. Just go ahead and click on the classification learner app. Okay, so that would open up the classification learner app. Now here you can apply different set of machine learning algorithm on this corresponding data here. Okay, now I have the classification learner app which is loading in. Let it load in. Right, so I have the classification learner app. Once I load the classification learner app, I can just go here and then say from workspace, because in MATLAB I've already loaded the data set. Okay, so I can just go here and then say from workspace. Okay, now you can see it is a Fisher table data with 150 cross 5. So where you have sepal length, sepal width, petal length, and petal width. Okay, and then there are species which are unique. So I can just say, you can just see here, this is my table data which has 150 cross 5. Okay, total 150 samples with 5 different features. And then what I can do here is that I can just increase the cross validation fold. So if there is any overfitting, that is being reduced by the concept of cross validation. Okay, and then I can just go here and then say start session. Okay, now what it will do is that it would load my data set into my machine learning model here. So you can see that it would take 1 minute. Now this is my scatter plot which it is plotting in. So blue represents what is called as setosa here. Okay, red represents what is called as versicolor, and yellow represents virginica of whatever data set we have. Now, you as a designer or as a student who are trying to develop machine learning algorithms, you need not study the huge concepts of programming. So you can use this app and then you can build applications, which I'm trying to show you. So if I go to this drop down here, in MATLAB, there are currently most of the machine learning algorithms. It might be in terms of decision tree. Under that, there is fine tree, discriminant analysis, logical regression, logistic regression. We have naive Bayesian, SVMs, that is support vector machines, nearest neighbor, assembler classifiers. So like that, there are different machine learning algorithms which are out there. Now, you as a designer can go ahead and select any of the machine learning algorithm. Okay, and then once you have selected the machine learning algorithm, you can just come down to the train here and then just go ahead and then click on train. Now, what it will do is that my system is having an SSD and it is having somewhere around 12 GB RAM. Now, if I go to my home tab here, okay, so you can see that it is starting the parallel pool of my machine. Okay, so imagine I was telling about if there is a system which is a i3 or a i5, it will have 4 cores on it, and then NVIDIA has how many? 256 cores. Now, when I've turned on MATLAB and then turn on the parallel pool, out of 4 cores in my settings here, I've said that I want 2 cores to be turned on. Okay, for MATLAB application, so that it can increase the speed of operation. So in MATLAB, we know how to know the execution speed of any program. We can use the command called as tick-tock, and then when you run the program, it will tell you that this is the amount of duration for execution. But that is not what I'm trying to do here. I'm trying to turn on the parallel pool. Okay, so to turn on the parallel pool, one option is that you can come and click here or in the home tab. Now it is, since it is busy, it's not allowing me to go to the home tab. You can go to the home tab. There is an option called as parallel. You can click on that icon. The parallel pool would turn on. Now here we are using 2 pools for MATLAB. You can see it is trying to turn on the parallel pool. If you have connected your system to the cluster, okay, via MDCS, you can actually turn on all the pools in your system, and then you would be able to work on MATLAB effectively. Now you can see that the number of workers is how much? 2, and this would be running continuously for another 30 minutes is what it is telling me. And you can see the details here. So it's saying that, okay, I have turned on the parallel pool. The number of workers allocated to MATLAB now it is 2. out of 4 workers, I have allocated 2. Okay, so you can see it is opening the parallel pool. Yes, it is opened. And then here, now your training process will start automatically. So you can see that the training process has started. Once the training process completes, it will tell you the accuracy. Like if I'm using tree algorithm, classification of model would be this, and the accuracy of this would be this much. So on real time, you would be able to get it. Okay, so this is with respect to what is called as tree algorithm, where you have an accuracy of 94.0. If I go here and then I can just click on one more machine learning algorithm, that is if I go here and then if I can just go here and then click on linear discriminant, and then if I go ahead and then train it using linear discriminant based machine learning algorithm, now you can see it is queued and it is performing the training on real time. You would be able to get better accuracy. Right now, if I'm using linear discriminant, it is telling me that if you are using me, my accuracy is 98%. You can go ahead and then select all, but it will take a lot of time. Let me just select one more, that is I'll say linear SVM. Let's see how it will perform. Right, I have to just select the machine learning algorithm and then click on train. It would perform the training on real time and then you would be able to process it. Right, so the linear SVM, it's 95. So the highest is which one? The highest is linear discriminant. Okay, so I can just go ahead and then once I have collected what is called as the linear discriminant analysis, I can just go here and then click on confusion matrix. So my accuracy is whether my flowers are going to get classified correctly or not is what I'm trying to analyze from this corresponding data set here. Okay, so what you can see here is that if I'm using, say, linear discriminant machine learning algorithm to classify flowers, you can see that setosa getting identified as setosa. Out of 150 samples, 50 samples are getting identified. Setosa got correctly classified as setosa. Versicolor, you can see that versicolor got identified as versicolor. It is 48 samples. But versicolor got identified as virginica. There is an error of 2. So whatever is along the diagonal axis here, it's basically the correct classification. So along your x-axis, it will be basically your true class, and along the along your x-axis, it will be basically your predicted class, and along the y-axis, it will be your true class. Okay, so actually the flower is setosa, but it got predicted as setosa. But again, your flower is versicolor, but it got predicted as what? It got predicted as versicolor, or versicolor got predicted as setosa. It is 0. Versicolor got predicted as versicolor. It is 48. Versicolor got predicted as virginica. It is 2. Virginica got predicted as setosa, 0. This got selected as versicolor, 1. And this got selected as this one, it is 49. So along whatever is the diagonal, you are able to get the correct classification using linear discriminant. The same would not be, the confusion matrix would not be similar in terms of decision tree also. Okay, now if I go to tree, now you can see the error margin is more. This is the confusion matrix of tree. So in machine learning, as we discussed, there are different machine learning algorithms, right? So applying machine learning algorithms and checking the accuracy, okay, only accuracy is not one measure. Okay, we have precision, we have different kinds of things which we analyze. Okay, we have F-score, and there are different methods. As we go in the afternoon session, I'll discuss on that, because we are going with the handwritten code also. We'll load a data set and then we'll be doing the handwritten programming. Now this is only with the app. Now where you can see that we have applied different kinds of machine learning algorithms on it, and based on the machine learning algorithms, you are classifying the data. Okay, now this is with respect to Setosa, versicolor, and virginica, which is basically the flower data set, and then you are trying to classify them. You'll also be able to check the parallel coordinates, how exactly the neural network layer or the network layer or the coordinate plots are out there. So it will take 1 minute. Right, so the prediction model, whether it is correct or incorrect, okay, the coordinates you'll be able to see, and you can see that the blue represents Setosa, red represents what is called as versicolor, and then you have yellow representing the virginica. So you can go ahead and then find out the different values associated to the model predictions, where there is standard deviation, that's your statistical method, and then you have the math which is running at the back, through which your layers are getting identified whether it belongs to which category of flower. Okay, so this is with respect to the parallel coordinate. And then once this is being done, I can just go here and then say export. You can just go here and then say export model. Okay, so let me keep it as trained model. Okay, and then click OK. And once I have the trained model, okay, I can just minimize this. Okay, this is my trained model. Okay, and I have written one set of code here, okay, where I have randomly entered the sepal length, petal width, and then once I've created a table, and then I'll try to fit that model here. Okay, so what I can do here is that I can just go into the editor, because I already have the trained model. So I'll be using what is called as trained model to predict whatever data which I have loaded in. So it is in the same format. Okay, I create a table here, table of these variables, and then I'll be fitting it using the trained model which I'm using it. So I can just go here and then run this corresponding model here. So you can see here the first set of flower, it says that after whatever the machine learning algorithm we have used, it says that the first set of flower 2222, it belongs to versicolor. Then you have rest of the flowers till the last set, that is still here 77, it belongs to flower called as virginica. The last flower here, it is nothing but your Setosa. Okay, so based on the sepal length, sepal width, and petal width, you are able to load a new data set and then you can classify it. You can also generate functions from here. You can just go here and then say export and then say generate function. Okay, where you can directly generate functions on real time. Okay, where you can see that somewhere around 90 lines of odd codes you are able to generate within no time. Okay, so this is with respect to the classifier learner app. And then you can also export the plot into figures when you're trying to publish papers and all. You would be able to requiring that. You can also see the accuracy, total misclassification, prediction speed, training speed, and so on. Okay, you'll also be able to see the covariance structure and the optimizer options available in the model. Now, once this is being done, let me just come down here. We just saw that we had loaded a data set and then we applied different machine learning algorithms. So what did we analyze from that is that many permutation and combination methods are generally used to fit and get the better accuracy of whatever model which you have created it. Okay, so if I want to have a machine learning algorithm where I'm having an app, and then I'm taking a live picture of that corresponding app, what would happen is that I have an input, and then I would be able to classify that input using Daisy, Lily, and Rose, and then I will be able to classify that. So what we did was we took these three set of flowers, that is Setosa, versicolor, and virginica. We measured the sepal length and sepal width, and then you can put your own data set, or you can use whatever data set which you have in, and then you would be able to classify that data using different machine learning algorithms. You can do it for text also, where we have an OCR trainer. So you can have your custom languages, and then you can identify different letters in different languages. It might be in Telugu, Tamil, Malayalam, Kannada, right? So you can pass on the data set here, apply edge detection, and train the what is called as the OCR or the characters, and then you would be able to get the evaluation of whatever model which you will be creating. Okay, so these are the data set which we loaded in, and then we applied machine learning. And via machine learning, you can select all the machine learning algorithms also. And then when you say train, it would give you the accuracy of each and every machine learning algorithms like this in parallel. Whichever machine learning algorithm gives you the highest accuracy, you can take that machine learning algorithm, and then you would be able to what is called as check the confusion matrix and visualize the data on real-time scenario. Okay, so in machine learning, to recap what we just covered, we have clustering, classification, and regression. In that, we took classification as one of the example. But as far as machine learning is concerned, imagine you are given with 3 set of cards. Okay, and then someone tells you to group that card. Okay, so when you turn around the card, you can see that there are images of cat, dog, and a bird. Okay, you may group it like this, assuming that they are animals. You may group it cat and dog in one category and bird in another, or you may group it like this, assuming that everyone is a non-vegetarian, right? So it depends, right? So all the 3 people have grouped it because there is no output here, output class here which has been given. So grouping them together is nothing but clustering. What is meant by classification then? Dog will have its own features, cat will have its own features, and then bird would have its own features. So based on features like the length of the nose, length of the mouse, ear size, whiskers, so there would be features. So based on that, you would be classifying them into category that this data set belongs to dog, cat, or a bird. Okay, so when you pass a new set of data, you should be able to classify that it is a dog, cat, or a bird. We did it with the flower, right? We took a random data set, we generated a function from whatever classification model we have, and then we passed the data set. It was able to tell us whether it's a cat, dog, or a bird. So what about the maximum running speed? So what is regression then? So in regression, we set numerical data. So if you look into the running speed of different animals, including dog, cat, and bird, it is between sloth and the cheetah. Now, if I talk about the speed of animal, if the running speed is between this and this, then I can just say that it is a dog. This and this, I say that it is a cat, and this and this, it is a bird. Okay, so it would be in terms of meter per second. So based on that, you would be able to classify it. You can also classify it in terms of weight and length or leg length, where you would be having numerical data only in terms of classification. Okay, so like this, you can use different machine learning algorithms. Okay, so one such kind of machine learning algorithm in the afternoon session we would be focusing is, we'd start our session with one machine learning algorithm where we load the sensor data into MATLAB from your mobile phones. And how to load that sensor data from your mobile phones into MATLAB, we'll check that. Based on that, you would be able to predict whether the person is standing, sitting, or moving in. So you can also predict something called as patient is falling, fall risk with machine learning. Okay, so is there any risk or such kind of things also can be done using various sensor data. So this is one thing which we'll be doing in, where you would be taking the live data from your mobile phone, based on which you would be applying machine learning algorithm on it. And then you have to identify whether the person is sleeping, standing, sitting, walking, or moving. Okay, so this approach will go ahead and start up exactly at 2 o'clock, and exactly at 11:55 I'm just stopping my session here. Okay, so from scratch we'll see how to take the sensor data into MATLAB and then apply machine learning on that data set. Followed by that, we'll switch to the deep learning algorithms, and if time permits, we'll also discuss how to deploy those algorithms on hardware. Okay, so that's it from my side for this. But before that, if there are any questions in whatever concepts or in whatever things I've covered, you can just put it in the chat box. Can you name few links from where we can get COVID data? COVID data, I'll be sharing you. I'll share you those data set. Okay, end of the session, like in deep learning, like COVID data set associated to lung expansion and whether it is diseased or unddiseased. That data set, we have it in the afternoon. I'll share you that data set. There's one question here, sir. When we use these data for our own programming, yeah. See, already these data set has been published, and these should be having a copyright also. So whatever websites I just showed you there, so the GitHub data, there would be some copyright things also which should be mentioned. Whenever you download a data set, there will be a text file. Please open that text file where they would have mentioned the copyright details. So that would give you a validation of whatever data set you have it. So whichever data set which you download from a specific website, they would be having the details associated with the copyright, right? So such kind of data set, you can obviously go ahead and use it. So there's a question see, there are various portals where you can get data set. If you go to my LinkedIn profile, you can see that there are apps which have been already created by the MathWorks team where you can directly import different COVID data sets. Okay, so please share your mail ID. I'll just share you those links, okay, after the session. Or I'll share to you my mail ID, or you can just send a mail to Ramesh Naidu. He'll share me the details and I'll share you those links from where you can download the COVID data. There are different set of COVID data. It might be in terms of deep learning, identifying people, whether they are suffering from COVID or not, or it might be in terms of the chest X-ray images. You are trying to analyze some things, right? Whether it is affected or unaffected, right? Or it might be in terms of blood samples, or it might be in terms of whether that person is wearing mask or unmasked person. Like there are different data sets. Okay, so depending upon I'll share you that link where you'll be able to get the different COVID data sets also. What is the basic requirement of system to conduct machine learning project? It would be ideal that you have an i5 processor with an SSD. That would be ideal. Minimum. That's the minimum. Yeah. But if you have a Jetson Nano or Pink platform, you can run the algorithms on that also. So directly via Jupyter Notebook, you can program run the algorithm on your FPGA. So that would take you to an IP level based project. So you can go for patents, yes. Yeah, thank you. Any other questions? Thank you. Thank you.
Answer is, sir.
Hello.
Pramod Garu, myself, Dr. Sridhar, coordinator of this. Thank you very much for enlightening us.
Yes,
so
sir,
hopefully by 1:50 or 2 o'clock, we shall commence the session. Exactly.
Yes. Yes.
So meanwhile, the participants, if at all you come across any questions or doubts, you can get them clarified in the afternoon session.
And so then you can go ahead with Laura also.
Expecting you all to come out with more questions and interact with the resource persons. So thank you one and all for your patient listening. So Nancharagar, you can wind up the session.
Yeah, Ami Joes, afternoon we have the DL and what is called a self-driving car demos. Please attend the session. I think that would be helpful in the afternoon. Okay, we have a big syllabus. Please bear me because with the slides and with one day, it's very difficult. I'll try my best. Yeah, thank you. Yeah, we have it in the afternoon. Yeah, thank you so much. Thank you, everyone.
So there's a hand raised by Chandra Prabha. I guess you can answer.
Yeah, sir. You can just unmute her, sir. You're unmuting her, sir?
Yeah, Nancharagar. So somebody is asking entry-level chip for IoT.
Yes, sir. I just mentioned that entry-level chip would be your Arduino board with some sensors like normal DHT11 sensors, and then you can also have an ESP8266, which is a Wi-Fi module. Okay. And you can integrate both and then you can start up, or you can go ahead with a bigger version. Is like Raspberry Pi models are also there. And then if you are planning for some industrial applications, like there are LoRa IoT platforms also. I'll show those demonstrations in the afternoon. I have something which is like a video. I'll just show you in the afternoon.
Okay.
Yeah. Thank you.
Okay.
Thank you, sir. Yeah.
Right, sir. Can we start our afternoon session a little bit earlier, Any some 1:45 or so?
Yeah, I don't have problems, sir.
So that the participants can have more time to learn more things. Right,
Yeah,
sir?
sure, sir. Sure, sir. Sure.
So we will do like that, sir. So requesting all participants, the afternoon session will start at 1:45, so that we'll have more time to have a hands-on session and going to a different number of examples taken over by the resource person. So kindly log in by 1:40 or so, all the participants. So I guess we can end the session here, sir.
Okay, sir. The link will be active for the whole day. So everybody can leave and join back with the same ID.
Nanchare garu.
Yes, sir.
మధ్యాహ్నం మనం 1:45 అన్నాం సెషన్ సార్ గూగుల్
Sir, the session will be active for a whole day, sir.
Great. Okay.
They can leave and they can join back at 1:45. No problem, sir.
Yeah. Okay.
Okay, sir. Thank you, sir.